Good morning, my dear friends. See now, in a sense, in the last class, we have seen how to calculate the stresses in PSC beam by using your stress concept as well as the strength concept. And the last concept what we have is, it is the load balancing concept. Okay. So now, let us try to see what exactly this load balancing concept says. And now, this load balancing concept is a very, very important concept because it is going to teach you so many things of your precious concrete. So in this class, we are going to learn so many things about our precious concrete, okay, after knowing this load balancing concept, okay. So, Baba, this concept is given by T.Y. Lin. T.Y. Lin is considered as father of your priestess, okay. So now, what he says is, see now, please try to understand very, very carefully, okay. What T.Y. Lin says is, okay, suppose if I keep the cable in this parabolic fashion, something like this, in a PSC beam, okay. Now he says, and if I apply the pre-stressing force, in the sense, assume that I have stretched the cables and I have anchored it, now, okay. Now after anchoring, T.Y. Lin says that this parabolic cable can produce an upward thrust like this at every change in the direction of the cable. In the sense, wherever the change in the direction of the cable occurs, there a upward thrust is going to be developed. Okay. So now, since this cable is changing its direction at each and every point, okay, now I say that an upward UDL is going to be produced in this system. Okay, an upward UDL is going to be produced in this system. So now this upward UDL, whichever is now going to be produced in this system, okay, can now balance this downward UDL, whatever I am going to now put on the beam. Is it right or not, sir? That's why we call it as load balancing concept. In the sense, this downward UDL, okay, is balanced by this upward UDL, whichever is now going to be produced because of the application of the pre-stress. This is what your T.Y. Lin says. Okay. So now, the question is, what is the magnitude of this upward UDL or upward thrust magnitude? Okay. So now, let us assume that this is the sag H of the cable. Sag H of the cable is H here now, small h, and I have applied here a pre-stressing force F. Okay. So now, Baba, there is a small derivation, but no need to worry about that derivation. Directly, we'll try to. I will give you one equation wherein it gives me how much is the upward force developed or upward UDL that is going to be developed by the pre-stressing force. See now the equation like P is equal to F into 8H by L square, or I will call it as 8FH by L square. 8FH by L square is the equation which gives me the upward load or the upward UDL intensity, okay, where F is the applied pre-stressing force, 8 is 8, and H is the sag of the cable, L is the span of the beam. So everything I know here, 8FH by L square. In the sense, I know how much is the pre-stressing force I have applied, and I know the sag H, and I know the span of the beam. So by knowing this, okay, all these quantities, I can easily calculate how much is the upward UDL that is going to be produced. Okay, so this equation you will have to remember. So now, what happens here is now, suppose this P is exactly equal to the downward UDL whatever I have applied. Say for example now, okay, here I have applied some W, okay, UDL, and this is your sag H, okay, this is your L, span of the beam now, okay. So now, as I said, okay, this is going to produce an upward UDL like this. An upward UDL is going to be produced in this system, and this upward UDL intensity is given by this equation, P is equal to 8FH by L square. suppose this P is exactly equal to this W. Okay, if this P, whichever is now going to be developed upward thrust, okay, if this P is exactly equal to W, then I say that this downward load W is exactly balanced by this P. Am I right, sir? Now they are going to be balanced. So since they are going to be balanced, the beam doesn't bend like this. The beam doesn't bend. Only it is subjected to a precessing force F. In sense, it is now subjected to a concentric precessing force F. Okay. So now, if at all you want to find out the stresses in the beam, Baba, it is now F is equal to F by A only, because it is subjected to only the precessing force F. Okay. And this F force is going to produce a uniform stress of uniform stress of F by A. Okay. So now, suppose now, if suppose now W applied is greater than P. Okay, if W applied on the load, the intensity of the load applied on the beam is greater than P, then Baba, find out what is the unbalanced load. W minus P will give me the unbalanced load. Am I right now? Okay. So now find out how much is the bending moment that is going to be produced by this unbalanced load. Okay. M is given by W minus P is your unbalanced load. Okay. Into L square divided by 8 will give me the bending moment due to this unbalanced load. Am I right now? Unbalanced load is W minus P. Okay. So now this unbalanced load produces bending moment M. Am I right, sir? Now, so now if at all you want to find out the stresses in the concrete or in the PSA beam, it is now as usual, it is F by A. Okay, plus or minus. Okay, sir. Now plus or minus, it is My by I, where M is, Baba, it is this M. Okay, it is unbalanced, it is the bending moment produced due to unbalanced load. Okay, so M is this M. So find out this M and find the stresses in the concrete or in the PSC beam. Okay, that is what your T-Lin says. Okay, so now ultimately, my dear friends, the equation is F by A plus or minus My by I, and this M is due to unbalanced load of this W minus P. Okay, did you understand or not? Now this is how we can find out the stress in the concrete beam. Okay, suppose now assume that I have applied here a concentrated load W. Okay, concentrated load W. But in this case, your T-Lin says that it is better to keep the cable in this fashion, in the triangular fashion. Okay, it is better to keep it in the triangular fashion. So now, when you keep it in the triangular fashion, now you know that T-Lin says at every change in the direction, there produces an upward thrust. So now it is changing its direction here. So now it is going to produce an upward point load V. Understood or not now? This is going to produce an upward point load V. And now you will see that this V is going to counterbalance this W. Okay? If V is exactly equal to W, now I say that the loads are balanced completely. The loads are completely balanced. If suppose, okay, if this W is greater than V, okay, then Baba now I can find out this thing now. Okay, I can find out the bending moment due to this load. Okay, W minus V, and I can find out this thing now. Now, according to your T-Lin, the intensity of this force W intensity of this upward thrust V is given by simple equation V is equal to 2F sin theta, where F is the precessing force applied and theta is the angle of inclination of the cable. Okay, theta is here, either here or here. Okay, so this 2F sin theta will give me the upward force V. Understood or not now? So now, if V exactly counterbalances this W, if V is exactly equal to W, then now your stress in the system is now, it is only F by A. Okay, stress in the system is now, it is only F by A. It's only F by A because your W is exactly counterbalanced by your V. Suppose, okay, Baram, suppose if now this W is greater than V, say now, if this W is greater than V, then find out your M first. Okay, in a sense now it is given by W minus V will give the unbalanced load, okay, divided into L divided by 4 because it's a concentrated load. So W minus V is the total load which is now acting, okay, L by 4 will give me the bending moment. And this, because of this bending moment, okay, there is some bending moment in the beam. So again you can find out the stresses by using this same equation, F is equal to F by A plus or minus My by I, where M is because of this unbalanced load. Okay, so now this is how you can find out the things by using your load balancing concept. So basically what your T-Violin says is now pre-stress concrete can balance some of the loads which are acting on the beam. So now another important thing what you have to learn here is now, see now, your T-Violin says that if the beam carries UDL, okay, then it is better to put the cable in the form of a parabola. And just now we have seen, if the PSC beam carries a concentrated load W like this, it is better to keep the cable in the triangular profile so that this upward thrust V can counterbalance this W. Okay, sir, now. So what you are going to see here is now, Baba, if the cable follows the bending moment profile, say for example now, if this beam carries a UDL, okay, then the bending moment will be something like this, parabolic. Am I right, sir, now? So it is better you keep the cable in the parabolic fashion. In the sense, your cable profile should follow its bending moment diagram. For example, now here now, the bending moment for this concentrated load is like this now. Okay, you will see that it is in the triangular fashion. Am I right now? So now, whenever there is a concentrated load, it is better that your cable should follow a triangular profile, or it should follow the bending moment diagram. Okay, I will give another example now. If suppose I have got two concentrated loads on the beam, if I have got two concentrated loads, Baba, it is better that I should keep the cable profile in this fashion because bending moment diagram is in the trapezoidal fashion. Okay, so it is better that I should follow the trapezoidal path for your cable. So wherever there is a change in direction, here also it produces one upward thrust, and here also it produces one upward thrust. So these two things can balance this load. Okay, so this is what your load balancing concept says. In the sense, load balancing concept along with your how exactly we can calculate the stresses, but it also gives one more important concept, okay, that your cables should follow the bending moment profile, something like this. Okay, so this is how the load balancing concept gives you the entire description. Okay, thank you very much, my dear friends.